The machines are iconic. The badge legendary. For over 100 years, Porsche has successfully built petrol-based sports cars. But now worldwide fossil fuel reserves are dwindling. Danger looms just over the horizon.
The question was not how could a super sports car look like. The basic question was, is there a future of the super sports car at all?
To endure, a team of elite engineers bravely faces the future.
The brand core is racing, is sports cars, and without the core you cannot survive.
The survival of the company requires reimagining the very concept of the sports car.
Companies like Porsche need a halo car. Cars that showcase new technologies.
The brand's future hinges on transforming technology engineered for economy and turning it into pure speed. The result? The Porsche 918 Spyder. In the early 21st century, global oil prices surge. Instantaneously, the automotive landscape changes.
Fuel economy is important because of emissions. Frankly, the more fuel you burn, the more you're going to emit. The European legislation in particular is looking at the total amount of gasoline a car burns.
After years of ignoring environmental realities, automakers are forced to act.
The times have changed. The questions which are asked by the publics are totally different.
As fuel economy numbers move to the forefront of consumers' minds, thirsty sports car sales plummet.
This is a company that's known for its sports cars. It now does make SUVs, it makes sedans, but it's the sports cars that define this company.
Overnight, the brand's flagship vehicle, the 911, is in danger of becoming a relic. The future of Porsche is at an impasse.
Everybody is discussing about energy resources and environmental pollution.
Porsche's answer is to boldly introduce a radical new concept car at the 2010 Geneva Motor Show.
We had the plan to show that a super high-performance car can also be super efficient.
The 918 Spyder concept car immediately blows the audience away.
The audience did not expect what they see. Nobody wanted to believe that it is possible to have one of the best super sports cars in the world, but on the other hand, having a car which is consuming energy like a mid-size car.
The machine represents an attempt to make a leaner and, more importantly, greener kind of supercar.
When this show car is projected, also a technical concept is lying behind it.
It's something that the board of directors say, well, this is what we want to do.
Immediately, the 918 is greenlit for production.
This is a task I knew it will be the next step of supercar in Porsche. From the very first day, the hope that it is not just a show car, but that it becomes also series production.
The target is to have the first machine roll off the assembly line in just over 3 years.
This is a very short time to hit all the deadlines.
There's only one problem. The team behind it doesn't know if they can actually produce it.
There was a clear vision where to go, but in fact no technical solution. And so we sat down on the table a couple of days after the Geneva Motor Show and said, okay, it seems to be we have to make this car. Oh, how can we do it?
Dr. Frank Vassler is the man leading the team, transforming a show car into a living, breathing hypercar.
If people know their target and we can visualize it, then it's clearer in their mind every day that we have a very, very tough schedule. So we bought this clock and that was counting down every day.
Just 1,095 days to reinvent the automotive world forever. And perhaps give the brand a new future. The difficult deadline is overshadowed by the project's lofty expectations. The board mandates two contradictory targets.
The first is the economy. It must not consume more than 3 liters per 100 kilometers.
3 liters per 100 kilometers is the equivalent to 78 miles per gallon.
The second is to have the best time at the Nürburgring. In our opinion, the Nürburgring is still the principal measure for supersports car.
High performance and high fuel economy typically lie on opposite ends of the automotive spectrum. The Porsche corporate board wants a production machine that can do both.
The show car had only ideas on the technology, but no really engineered solutions.
Every aspect of the new machine either pushes technology forward or forces the team to create it.
There was a small group of engineers working on what could be feasible, how could it work, and of course we're the designers making interior, exterior design.
You have the design and then the hard work starts because you have to fight it through with the engineers, production people and everything.
The big challenge in making a supercar with all this hybrid technology in it is how do you make it all fit within existing supercars? You can't have a supercar the size of a bus.
To meet the deadline, engineers borrow concepts from two of the most famous Porsche platforms ever built. The ultra-exclusive and hallowed Carrera GT supercar and the highly successful RS Spyder Le Mans prototype.
We have learned a lot of things in the racing, and we have also learned a lot of things in the Carrera GT. This experience and this knowledge we brought together in the 918.
Only 1,720 units of the Carrera GT were ever built. The machine's value doesn't lie in its exclusivity, but rather the carbon fiber used to build the machine's monocoque frame. Engineers decide that in order to satisfy the 918's two performance targets, they must use a similar strategy to save weight.
The key enemy for a sports car is weight. The concept had to be that the car has to be super light.
The team also borrows the engine technology derived from the RS Spyder racing machine.
We have to take a race-bred engine, our V8 engine from our successful race car.
A 608 horsepower, naturally aspirated V8 engine. The proposed powertrain combines the Porsche racing V8 with two electric motors.
It was clear that we want to have 3 power plants, the combustion engine and 2 electrical motors, but it was not clear what electrical motors we have to use, where we can get it, what cooling is necessary, what power supply is necessary. That is the task of the realization phase.
In the beginning, we had no idea. But we just started to make it.
When you look at the 918 Spyder, you can't help but go, oh my God, are they really going to build this?
There was a lot of passion in the people saying, we show the world it will work.
I remember at the first days of the serious project, I met the guys from the production first, and they said, oh my God, you cannot build this. And I said, yes, we can. We will find a solution.
The theory is clear, the course of action is not. And the future of the marque hangs in the balance. There are less than 700 days left for Porsche to reinvent the supercar. A race the company can't afford to lose.
We really invested heavily and a lot of time in details of the design, as this will be a blueprint for the next sports cars.
It's for sure, from technology point of view, the most ambitious project in the industry.
Although the Porsche brand is known for petrol-based sports cars, it has a unique history with electric motors.
When Ferdinand Porsche started to build his first cars, he used already electric motors. He thought perhaps an e-motor is more reliable than a combustion engine.
In 1900, Ferdinand Porsche builds the world's first electric car. It featured a 2.5 horsepower electric motor and conceptually was ahead of its time.
In the year 1900, there were a lot of people thinking about electrical motors will be the answer. But they had also the big problem where to store the energy. And batteries were unbelievably heavy.
Fast forward more than a century, and engineers at Porsche again face a similar problem.
The lighter a car is, the better. But for a hybrid, it's again different. How big is the battery? How much energy do we carry around?
Engineers determine the 918 needs a 312-cell lithium-ion battery unit that can hold 6.8 kilowatt-hours of power. That's the equivalent of over 2,600 AA alkaline home batteries.
If the battery is too small, then you will not benefit from the power you have in the car.
Engineers face a balancing act. They need powerful batteries to push the performance edge. But, like in Ferdinand Porsche's day, power adds weight. The heavier the machine is, the slower it will go.
A lot of people believe performance is just a number of horsepower. And this is wrong. Power-weight ratio is very important.
When you're trying to determine whether or not the sports car genre can survive, no expense can be spared. Engineers liberally use carbon fiber not only on the outside, but on the inside of the machine as well. The goal? To create an extremely light body to offset the bulk of the batteries. The 918 features state-of-the-art monocoque construction.
Of saying that the passenger cell and all of the main structure of the car is one piece of carbon fiber. And carbon fiber is really carbon fiber reinforced plastic. It's a composite.
It's based on the biggest carbon fiber monocoque in the moment in the super sports car.
Carbon fiber is really carbon fiber reinforced plastic. It's a composite with carbon strands through it that's really strong and very light.
Engineers count every kilo, even in places you may never expect.
You're looking for a fast lap on the Nürburgring, you have to optimize everything.
The wheels are engineered for both speed and efficiency. Built from lightweight magnesium, they are collectively 14 kilograms lighter than traditional wheels.
Look at this wheel, which is the slimmest possible wheel you could do with a very, very special design. It was another thing where we didn't really know whether it would be strong enough to put all the power on the ground.
The result is a chassis and crash structure which weighs a scant 220 kilograms. With full bodywork, powertrain and batteries, the 918 tips the scale at less than 1,700 kilos. The powertrain is the heaviest part of the 918, so engineers put their racing-derived V8 engine on a diet inside a computer environment.
Here is the assembly area from the engine department. So all the prototype engines were built here before they went into the cars. We took basically every part and thought about how we could make it lighter. Maybe you can make this a little bit thinner or maybe another material.
To save weight, the engine uses titanium connecting rods, a carbon fiber airbox, and an oil channel that runs inside of the crankshaft. With the calculations complete, the team tests the new V8 on a state-of-the-art dyno.
High ref engine, that was one of the targets. We wanted to make it 9,000 RPM. On the other hand, we wanted to have a very light engine. The most emotional engine that we could think of.
The team places all that emotion inside the chassis with pure performance in mind.
The general layout of the car, the space where we put in the battery, where the engine is, where the gearbox is, where the driver is sitting, and then lower everything to make the car as stiff as possible.
Nearly 80% of the machine's weight sits below the centerline of the car, helping it achieve tremendous cornering speeds on a racetrack.
If your layout is right, then you have the best chance to make a really fast car.
Many auto manufacturers strive to build machines with an equal 50-50 weight distribution between the front and the rear of the machine. The 918 is different. Porsche's engineering team decides to put 57% of the machine's weight in the back. A historical nod to the company's 911 rear-engine knowledge base. While the future of the sports car might be in question, the Porsche philosophy is not. From the very beginning, Porsche has specialized in sporty machines that have the engine in the wrong place compared to conventional cars.
In the back of the 918 Spyder is a fairly conventional hybrid system. That means it's a V8 engine that makes all kinds of noises.
It's one of the lightest engines in the Porsche stable, weighing just 140 kilograms. As the team continues to refine the V8 engine, other engineers turn their attention to the two cutting-edge electric motors.
There's an electric motor that can start the engine, or it can power the car.
In the back of the car, engineers pair a 156 horsepower electric motor with the V8. They design the proposed electric power plant in yet another virtual environment. Then they test it in the real world on a unique set of dynos.
The cool bit is up front, where you'd normally have wheels that just steer and brake. There's an electric motor up there too, and that can power the car. Having an electric motor in the front and this combination of electric and gas in the back makes the 918 Spyder four-wheel drive and really fast.
That 129 horsepower electric motor comes to life inside the ZF factory in Friedrichshafen, Germany. The process starts with the assembly of the engine stator. It's one of two key components that make up an electric motor. The motor uses electricity to create magnetic fields that move around in a circle. A stator is the device that creates this force, and it encourages the rotor, which is connected to the wheels, to follow it.
We are in the factory for the first production step of our stator.
A technician places a lamination stack inside a welding machine. The stack looks like a solid piece, but it's actually 200 sheets of metal.
We start with connecting the coils up to the yoke. 24 coils on one yoke. It makes one stator in every 180 seconds.
Each bundle has 50 windings of wire. The wires are brazed, a process where solder is heated up to 650 degrees Celsius in order to connect two electrodes together.
We go down to 1/5 tenths of a millimeters in tolerance. A third of the thickness of the human hair, for example.
The stator looks complicated, but it's actually the easy part. The rotor is the challenge. It houses the stator. Its job is to use electricity and magnetic force to create movement.
These red parts here, this is the stator, and here we have the rotor, the outer part, that's rotating.
The rotor uses 32 very special magnets to do it.
The force of these magnets we use is about 40 to 60 times higher than the magnets you would use on a refrigerator. They are responsible for the power, the torque you get out of this electric system.
Those magnets are held in check not by bolts, but rather glue. After the stator and rotor are joined, it's time to install the torque damper and the flywheel. Finally, the electric motor is ready to be packaged and shipped off to Zuffenhausen, Germany.
Even if they have the nominal same figure, electric motors are more powerful than a combustion engine.
It takes months to sort out the revolutionary 3-engine setup. However, the solution presents engineers with a new issue.
We need to keep the battery cool. Therefore, we decided to bring all the heat sources away from the battery as far as possible. And that was the birthday of our top pipes.
The placement of the pipes is form following function. Having the exhaust exit from the top of the machine allows both the V8 and the battery to occupy the same space without overheating.
The top pipes are an extremely clever solution, and design-wise it's really cool.
We thought, what's the shortest way from the exhaust valves to the outside of the car?
In this simulation model you can see the effects of the hot exhaust air coming out of the top pipes.
The placement of the exhaust pipe solves the heat issue and helps the aerodynamics, but it also creates yet one more challenge. The exhaust gas exceeds 900 degrees Celsius, which will melt the carbon fiber exterior. So the team has to tune the airflow to avoid conflict.
When flowing downwards, the air cools down due to the surrounding flow.
The colleagues from aerodynamics can calculate a lot, and that made it much easier to check if it will work without having a real car in front of you.
In theory, the 918 is now light, powerful, and efficient. However, there's still one massive hurdle for the team to cross. They still need to test it in the real world. The end is in sight for Team 918 as they race towards a tightening deadline. After over a year of research and development, they're finally ready to build a working prototype. Now it's time to test the machine in the real world. With nearly 900 horsepower in a 3-engine vehicle that weighs just under 1,700 kilograms, the word fast may not do the 918 justice. The Team 918 still isn't sure how they'll control all that power.
We talk days and hours on the driving modes, how they should feel like and how the differentiation should be.
They test the cutting-edge driving modes in extreme environments. And take prototypes to Sweden, Africa, and Las Vegas.
We tested for 100,000 miles. We have new technology on board that makes it really, really complicated. But we learned week by week, day by day, hour by hour, how to test a hybrid.
After months of trial and error, 5 driving modes are chosen, each activated via buttons on the steering wheel.
We talk in particular about 4 positions of this map switch called E, H, S and R.
By default, the 918 starts in E-Power mode as a fully electric front-wheel drive only machine.
With this E-Drive mode, the normally aspirated engine is not running.
If a driver pushes beyond 150 kilometers an hour, or if the batteries run low, the V8 engages and the 918 becomes a hybrid. The combustion engine only kicks in when the electric motors need support. The Sport mode allows the 918 to flex its muscles.
We get the full power from the normally aspirated engine with boost from the e-drive system.
Now the race-bred V8 supplies the majority of the power. The combustion engine isn't the only support system that comes to life in Sport hybrid mode. The Sport Hybrid mode also engages the 918's active aerodynamics.
If you drive in a sporty way, then we tune the aerodynamics by raising our wing in the rear.
The tuning is done primarily via a front lip and rear spoiler. The wing has to deal with a tremendous amount of force.
We have air load at high speed from about 3,200 newtons.
3,200 newtons of force is equal to 326 kilograms. The weight of not one German scientist, but 3. The active aerodynamics also help redirect airflow under the machine. Next comes race mode.
It's really a very performant mode.
In race mode, both the combustion and electric motors are geared for maximum performance.
We actually get out everything possible from the eDrive system, even beyond the edges of the original design criteria.
Active aerodynamics also go to the extreme in race mode.
For race mode, you want to have the most downforce possible, and we do that by inclining the wing 8 degrees.
Downforce is an engineering trick that uses the force of air to push a sports car against the ground. At the center of the driving mode selector is a red button, which allows drivers to engage the 5th and final drive mode, the hot lap.
That is the mode for the hot laps on the Nürburgring.
Pressing the red button literally throws caution to the wind, or at least fuel economy. All 3 engines are allowed to go to the max. None of the computers care about preserving battery charge, pushing the 918 to its 339 kilometers per hour top speed.
People associate hybrid with slow, and that's going to change big time.
The Porsche team has raced against time to meet their design and efficiency goals. Only one target is left.
Everything comes down to a lap time on the Nürburgring.
The lap time is very important for us because the Nürburgring, for us, it's the basic measure for a super sports car.
The Nürburgring is the longest track in the world. This was an old Grand Prix circuit that is ultimately too dangerous to race on. But because the Germans love speed so much, they open it to the public, and they also open it for development.
Located 84 kilometers from Cologne, Germany, the Nürburgring is hallowed ground for automakers.
If you do 5,000 Ks on Nürburgring, it's the same like you make 60,000 on the open road.
A lap of the Nürburgring is every bad road you've ever driven on, plus every good road you've ever driven on, plus every amazing track you've ever driven on. And doing a lap gives you all these different conditions and really tests a car to its limits.
A car what is good on the Nürburgring is good everywhere.
Any brand who wants to make a perfect car comes back to Nürburgring.
No street-legal production car has ever cracked a 7-minute lap time.
We had less than 5 real serious attempts to make this record time.
We have been working towards this day very hard. You know, so many things can go wrong.
After just over 1,000 days, everything comes down to just 48 hours.
One lap, you have to prove everything of the car.
On the first day, the 918 falls short of expectations and a sub-7-minute lap time.
The fastest time of our race drivers was 7:09, 7:07, 7:06, and then I went in the car, made 7:04.
On day 2, the team brings in professional racer Mark Lieb, a 4-time 24 Hours of Nürburgring winner.
I was sure, and the next day, if the condition is good, I said to Mark, you will go under 7. It's no problem at all.
6 minutes and 57.
He said, listen, boys, think to this day in 38 years. The boys said, why? He said, 38 years you are as old as I am today.
The final lap time, 6 minutes and 57 seconds. The fastest lap ever for a street-legal car around the Nürburgring Nordschleife.
This is a number which nobody could imagine, let's say, even 5 years ago.
The 918 has the rare ability to be both a daily driver and a supercar. But now the team has to start building it for customers. And to do that, they'll need a cutting-edge factory. It's taken a team of engineers and designers just over 1,000 days to perfect the 918 supercar. Now they need to figure out how to build it. Zuffenhausen, Germany, has been both the spiritual and literal home of the brand since 1950. Inside of these hallowed halls, Michael Drolshagen is the man in charge of 918 production.
918 Spyder is a handmade product. We have no automation inside the workshop.
For years, the Porsche way has targeted assembly methods that maximize production efficiency.
We have to figure out how we can produce a car without the equipment of mass production, but to use mass production tools to improve the highest standard of quality we can get. The biggest challenge was to implement the new technology. It's not only one technology, it's not only hybrid technology inside the car.
The monocoque is the first piece of cutting-edge technology to arrive at the factory. It's just one of hundreds of new technologies in the car. New tech that requires an extremely efficient factory layout.
Keep in mind, we have only 4,000 meters in square available for the complete pre-production and production of the 918 Spyder.
It's a tiny space to handcraft a cutting-edge car. So Drolshagen splits the entire process in half.
On the one side you have the main line, and on the other hand the pre-assembly of all our parts.
The first half of the process begins with pre-assembly and the heart of the 918, the 4.6-litre, 608 horsepower, direct-injected internal combustion V8 engine.
We are right now in the engine area where we produce all our engines for the 918 Spyder. We pimped it up for the 918. It's a 918 color, acid green. We have 7 stations to build an engine. Every engine is built by one person.
It takes the engine builder 20 hours to bring a Porsche V8 to life. The V8 has been modified to be as light as possible.
The thickness of the wall here is around 3 millimeters aluminium.
That's nearly the width of a line drawn by a pencil. The entire power plant weighs just 140 kilograms.
It's more than 100 kilograms lighter than a 911 engine.
Another key area in pre-assembly is the leather trim department.
As you can see here, we produce our leather parts handmade in around 8 hours.
It takes twice as long to handcraft a 918 interior compared to mass-produced Porsches. Everything from seat pads to sun visors is hand-stitched with the greatest of care.
The Sun Advisor, we stitch 220 stitches and more than 90 minutes.
Once pre-assembly is finished, the 918 begins to take form on the main line.
We build the car on the engine, then we fit the part from inside to outside.
Working inside out is one of the unique concepts behind building the 918. The first step is connecting the V8 engine to the rear electric motor and the dual-clutch gearbox. What Porsche calls the PDK transaxle. The traditional hybrid powertrain is housed in the rear half of the monocoque, which is both light and strong, but isn't structurally sound until the engine is bolted into it.
This is like a bridge for the engine to fit the engine cradle together with the engine, the gearbox and the electric drive.
3 screws on each side turn the engine into a structural component for the vehicle. Then the whole powertrain unit joins the front half of the carbon fiber monocoque at station 2. The engine comes alive once both halves of the machine are put together.
We are now at the 3rd station where we start to build up the car from inside to outside. As you can see with the tubes, wiring harness, air intake sensor on it.
Here the monocoque can be lifted and moved to fit intricate systems like the wiring harness.
The monocoque was 140 kilograms and it's exactly the same weight of the engine.
Minimizing the weight of both the engine and the monocoque is one of the keys to the 918's performance on a racetrack. Another is keeping the center of gravity low. So they put the heaviest part of the car in the bottom, the battery.
This hole you can see here is for the high voltage battery. And with the cables is connected to the front electric drive here.
Once they finish wiring the battery, the 918 is ready for the last of its 3 power plants. The front electric engine. It arrives at the line already pre-assembled to the front suspension.
We have 3 hearts inside the car. The V8 engine and 2 electric drives. And we have a 4-wheel drive only by cable.
There is no traditional drive shaft connecting the engine to all 4 wheels. The 4-wheel drive system is run by a cable. The computer can continually vary the power split between the front and rear wheels.
What you can see here is the brake system of the 918 Spyder.
They very carefully install the rear brakes by hand. The 406mm custom Brembo ceramic rotors work in concert with the electric drive system to recuperate energy.
A big advantage of the cars, you have not only the standard braking system available, you have in addition 2 braking systems with the 2 electric drives.
While the 887 horsepower pushes the 918 to an insane top speed, the regenerative braking system can convert stopping energy into 230 kilowatts of power. That's enough power to run 183 American houses.
The benefit of a hybrid system is that you're recapturing a lot of the energy that would have gone wasted into braking.
Slam on the brakes, and the 918 goes from 100 kilometers an hour to a dead stop in 28.6 meters. Roughly 2/5 the wingspan of a 747 jumbo jet. Once the mechanical pieces are set, the 918 receives its bodywork. Now the machine is ready for perhaps its most famous part, the badge. A symbol that combines the historic colors of southern Germany and a black stallion, which has been an iconic fixture in Stuttgart's coat of arms since the 14th century. But the 918 isn't quite finished. It still needs a very important alignment check, because the rear axles feature electromechanical actuators that enable it to do something unique: steer the car from the very back. The rear wheels can turn up to 3 degrees in the same direction as the front wheels for enhanced stability at high speeds. Finally, after 3 years of research and development and countless hours on the assembly line, the very first 918 ever built, serial number 001, is ready. A car intended for Ferdinand Porsche's grandson.
Normally we do not talk about our customers, but 001 is Wolfgang Porsche. He of course ordered number one, and it makes the team extremely proud that the first car will go to a family member.
The very last station on the line is one of the most unique in the automotive world, because it's the quietest and perhaps one of the most expensive. The 918 has a base price of €636,000.
I think that most automotive engineers are hedging their bets and saying, right now, electricity is probably the best way for us to go for all of our cars.
Turn the key, and the latest Porsche supercar simply hums along, with the electric engines doing all the work.
You're not buying a 918 Spyder to go as slow as possible in traffic and use the least amount of fuel. Everyone who buys this car is going to drive it like a total maniac because that's exactly what it was intended to do.
Put the pedal to the metal, and all three motors come roaring to life.
Anytime you get into an electrically powered car, whether it's just a pure electric vehicle or a hybrid that's electric intense, it is immediate psychotic acceleration. It's unlike any gas engine.
After just one wheel rotation, the 918 is already going over 25 kilometers an hour.
The difference between turbo lag and a normally aspirated racing engine is this big. The difference between a gas engine and an electric car is that big.
The cutting-edge hybrid powertrain produces an astounding 887 horsepower. At its peak output, the 918's three power plants produce 1,280 Newton-meters of torque. The 918 catapults from 0 to 100 kilometers per hour in just 2.2 seconds.
The 918 Spyder gets to 60 faster than that.
At 300 kilometers an hour, the 918 covers 42 meters in half a second. Half the short side of a New York City block. It goes 0 to 200 kilometers an hour in just 7.3 seconds. Never slowing down until its maximum speed of 339 kilometers an hour. Yet the most impressive number could be its fuel economy. The 918 uses just 3 liters per 100 kilometers. Unheard of for a sports car.
The interesting twist on this one is that not only is it the state-of-the-art in speed, but it's also the state-of-the-art in getting good ratings on fuel economy challenges.
In the end, if it's then fun to drive, that is really an opener for new technology. And from that point of view, I think the 918 Spyder is an opener for really a new decade of super sports cars.
First, it was a dream. Then it was a concept car. Now it's simply the world's fastest four-wheel drive hybrid supercar.
It's always a challenge, it's always something interesting, sometimes it's unexpected. If you're working for Porsche, it's never a project that will be boring.
It is definitely not certain that electricity is the future. It is a future, I think. But it looks like every probable direction is heading towards electric.